Good morning, everybody, and welcome to SaltX Technology Holding Interim Report Q3 2021. Carl-Johan Linnér, CEO of the company. Together I have on my side here Harald Bauer, the CFO.
Good morning.
We have the pleasure now to give you the presentation of what we have done during Q3. And before we go into that, I would just like to mention that you all fully know about, of course, what's going on in Glasgow, the top level meeting with the climate discussions with more than 21,000 people participating in more than 200 countries. What they are talking about, as you probably know also, is that they're going to talk about how are we going to achieve the agreement from Paris 2015 with a global heating of lower than 2 degrees or 1.5 preferable. And that is certainly a critical thing to talk about and actually to come to some actions also. The present situation as we do have when it comes to the global heating is actually more than 2.7 degrees, which is very scaring and very bad, so we need to change that in a good way and make it possible to come to a fossil-free solution with the energy situation in the world. Having said that, we also realize and hope that you also as investors realize that we are on the right arena, so to say. Every day that we pass by, the increases the demand and interest of energy storages in one way or another, not necessarily only thermochemical storages as we are doing, but all other possible solutions also. Because the expertise and everyone says that if we are going to a fossil-free situation, we need around 20% in energy storage as a backup because of the fluctuation changes of the wind and sun. So that is just having said that, we're not going to spend more time into that one, but we feel really that we will be able to support the transition to a fossil-free situation. And they also said that what Greta was talking about 4 years ago is what they are talking about today. And also I heard another comment that India have also made a commitment now. They're going to be fossil-free by year 2070. But before they haven't said anything, but now they have said 2000. So it's 50 years, Harald. That's quite a long time.
The one who lives will see.
Yeah, right. Saltx Technology is a company that develop energy storage solutions based on our worldwide patent groundbreaking technology, which is the nano-coated salt. And that is really what we are building our competence on step by step and making it possible to come to this fossil-free situation. And what is very important then is that we are looking into scalable technologies, that we look into technologies that it's possible to scale up to megawatt sizes. And to be able to do that, we need key technical partners that we work hand in hand with. And today, I'm very pleased to say that I think we have that. We are working close with Saltx, Australian company for the charging reactor, and Sumitomo Foster Wheeler with the discharging reactor. And later on, you will also hear that describe a little bit more about, we have signed a partnership agreement with ABB to be able to control the process in various way, which is very, very important, of course, to control the battery. So our activities is certainly supporting the UN and all different targets with the climate actions and various sustainable cities and communities targets. The latest from SaltX is that we have spent a big portion of our time and efforts into the Stockholm pilot plant in Q3. Step by step, we have built we started with a discharging reactor with Sumitomo Foster Wheeler. We've done the design, construction, built the design on various parameters from our laboratorium, and we have created a new sort of fluidized bed solution that makes this possible. Later on, we have also, as a phase 2, we have designed a solution with colleagues, which is based on a falling bed technology. It's a 20-meter high reactor that are heating up the salt. And also, as the second phase is, as I mentioned, the ABB cooperation. And the ABB cooperation may seem that it's only the control system and the PLC system and so on. But once you start with those type of partnerships, you can also see that we have a lot of other things in common, like our values and the mission of an electrified industrial, not polluting the world too much. So there is a lot of other possible cooperations. And beside that, I can also say that we are talking, of course, with other possible partners in the future. Looking on what we have done then, our milestones, we actually, we started 2013, but you can say that from 2019 in April, we opened up the Berlin plant at Vattenfall premises, 0.5 megawatt size of charging and discharging reactor, 10 megawatt hours in capacity. And that was based on a spiral Joule solution in reactors. And we found out that to be able to scale this up, we needed to change the technology. And the plans was actually that we should change the discharging reactor to a fluidized bed in Berlin. But the corona came along, and the plant, the total industrial plant was closed down. So we decided that we should go for an own solution here in Stockholm. And so we did. And we are now at the very end of the mechanical installation of this pilot. And we hope that we will be able to start the test in best case at the end of this year, but more likely in the beginning of next year, and to be able to show you and present the results in near time. Also, we done the Helsinki Energy Challenge competition, and we were one of the 4 winners in that one. And that was a very promising and a good confirmation of our technology and our solution, which was actually based that we are an important part of the total fossil-free solution. And this was actually done with a local utility together with a mayor in Helsinki. So there was a lot of focus on that one. And that result that we had from this discussion here has actually opened up a few other doors to us in Sweden and some other places also, that we are talking to some utilities now that they have heard about this Helsinki Challenge situation, and they want to do a similar thing for them, not in such a big scale, but in a smaller scale, of course. So that is in a way that we are by doing a sort of a pre-study, we are telling the customers how and when and why should they use an energy storage solution. And that is very, very important. So yeah, and then we have earlier announced about the Luleå pilot, and that is an heat-to-heat application. We are going to use the waste heat, but we haven't started with that one yet. We are in a pre-study phase, and that pre-study phase will continue until the end of the year. And we will, next time we get in contact, if not before, we will inform you about what what we will do up here. But it's a very interesting, first of all, a very interesting place to be at, because there's a lot of things happening up in Luleå when it comes to green steel and other things also. But we are working very close together with Sverim, which is a branch organization that is owned by the metal industry by 80% and 20% by the government. So we are really in the sort of the bullseye of where things are happening. We are working with peak shifting, and to be able, I mean, the easy way to explain it is that we charge the battery once it's cheap, and we discharge it when the price is expensive. And this is, of course, getting more and more higher interest in because of the fossil-free situation. It happens. It never happened in the past, long time ago, when we were using oil and coal. But now it happens more often, even in Sweden, that we have negative electrical prices, especially if it's blowing. The wind is very heavy during a long time. We don't have. We need to export the electricity, and we need to. That is the time when you should charge our battery for later usage when the wind is not blowing. We are continuing focusing on our arena where we want to be. We want to be on the large size, which means that the capacity of 10 megawatt hour, even 1 megawatt hours is possible also, of course. But and we think that we should have a storage time of days, maybe weeks, because to take the advantages of that we have a thermochemical process instead of a sensible solution. That is where we have the best arguments and the best unique selling points, really. And the fact also that we have possibilities to have one size of the power to charge and another size of discharging is also a good thing in many of those cases. You want to charge the battery during maybe a long time when it's good weather or warm weather, and then you want to discharge it maybe during a certain much shorter time, and then you need another power, of course, to do that. So that's where we are. The core technology is based on the calcium hydroxide that we are charging up to. We're heating it up to 550 degrees approximately. Once we reach that temperature, the steam, the water will disappear from the molecules, and that could be used in a district heating way or other things. But the energy is then stored in calcium oxide, CaO, and that could be, as I said, could be stored for a longer time or a shorter time, whatever. It doesn't matter. You have the same energy in it over time. And once you will use this, when you have a very cold winter week or whatever in the city, you put on 120 degrees steam, and you get the chemical process that you release a lot of energy in 450 degrees Celsius steam, and then you are back to calcium hydroxide again, and then you can charge it once more, and you do the circular thing. And that is because of the nano coating making it is possible to discharge, to charge, to discharge, and so on in a repeatable way. We are working with 3 applications: heat to heat, power to steam, and power to power. I would like to say that power to steam in the middle here is the first top priority and where we have the longest experience in. We are building the Stockholm pilot, power to steam. Berlin was power to steam. But shortly after that, we have the heat to heat that we are doing this pre-study now in Luleå, as I talked about, and where we're actually going to plan for, and we're doing the study based on using the waste heat as a charging, and then we're going to use the heat also once we need it, more in district heating up in Luleå and so on. It's a very, very exciting and interesting arena because people don't very often know about this, but there is a lot of waste heat in the industry. And we need to, of course, to have the waste heat of 550 degrees then. And that temperature you have in the steel industry and in the ceramic and glass industry and otherwise. So the waste heat in Europe is huge when it comes to the industrial steel plants that is working there. This is a schematic build of how it could look like. We powered the salt with heat or gas or electricity. We have a flexible solution there. We do the charging from the top, the falling bed. We get out the calcium oxide in the bottom, and then we discharge it. We take out heat and or electricity. You could take out the heat and you could put it into a turbine and make electricity, and after the turbine you do the heat. So there's a number of opportunities here. It's not one standard solution that fits everyone. So that's a good thing, that you can also change the power in charging and the power in discharging, as I said. But the charger, we are working very close with an Australian company called Saltx. They have a long history of the falling bed technology. And for the discharging, we have working with a Japanese-owned Finnish company, Sumitomo Foster-Wheeler, that has more than 100 years of experience of fluid as bed. But they have the experience in fluid as bed of traditional applications, which means that they are burning biofuel, they're burning garbages and different things. So it's another slightly, well, quite a big difference actually, to use calcium oxide to instead of biofuel or biomass situation. So that is why the cooperation is so important, that they understand our need and we understand their need, how we should come together and make this up and running. Stockholm pilot plant. This is a huge effort that we have done during Q3, and it goes on in Q4 and also beginning of next year when we do the testing. As I said, we are at the end of the mechanical installation now. What you see from this picture here is actually the bottom of the charging reactor from Saltx, and we have made a video 4 or 5 minutes long that you can find in the presentation on the website in the report. But we will also release a special announcement of that one in social media later on. That will hopefully give you an idea of how much work we've been doing in this here. We have had between 15 and 20 sub-suppliers on every reactor. We have had electricians, we have put in sensors, transmitters, and installed an electrical PLC system to control the system, because this is a pilot plant, and that means that we need to take out as much information as possible in various positions. And that we are doing because we want to be sure of that we could scale this up later on into megawatt sizes. And we are having, of course, a number of parameters that we have a target on, and we want now to verify those levels. But it's all about level of hydration and level of dehydration and level of heating transfer coefficient and all those technical things that will work as a base to scale it up later on. But take a look on the film, and you will hopefully see more about it, how it looked like. It's a YouTube link that we will have. The Saltx ecosystem looks as the last time, I think, except for the ABB, which is very pleased to have on board here because of their knowledge and the experience. And we want to take them on board in our as early as possible when it comes to the designing of this energy storage application. And that is very important. Not that they could tell us if we should change anything, but they could probably recommend us to do various solutions. And as I said, also we have the same mission to electrify the industry, and this is also open up the door for them, ABB, to find new areas, and we can, well, as all the other partners here, we have a win-win situation. Application partners, Swerim is the most active partner now. We have a very tight, good cooperation with them, and they are supporting us with a pre-study in Luleå. And they have a very long history of the steel industry, and they can, and they are on the way to do that, come up with suggestions and proposals of how we could utilize our technology in the best way. EnerStore and Shanglian, we're still working with them, but they are a little bit not the highest priority right now. EnerStore wants to go their own way with own IP rights and so on when it comes to the reactors, so we let them do that. But as long as it's based on our material. Shanglian have tried now for some time to build their own pilot installation. The results have not been the best, but they are still struggling to get it, and we are in a discussion with them to maybe to formalize some sort of other cooperation agreement with them, but that's going to be a separate discussion. Then when maybe it will come to some sort of license agreement instead of only supplying the material. We will see about that. We are in discussion with them at the moment. This is a picture that we continuously live with, and we are updating it constantly. We are looking on our competitors and looking on where we are at the moment ourselves. But the situation is that if you see the blue table, that we have a outstanding energy density of more than 500 kilowatt hours per ton compared to the molten salt and compared to the concrete. What does this mean really in concrete terms? Well, it means that we have a more footprint effective solution, that we can have higher energy based on certain per square meters, which is very useful in cities and so on. The capex is of course a tolerance minus plus, but around 100 euros per kilowatt hours, translated into Swedish currency is about 1 million Swedish krona per megawatt hours, and that is of course subject for constant improvement, but that is where we are at the moment, and we are not that far away from the competitors, which is very good to see. The good thing is that we are using the material that is environmental friendly, and it's a lot of calcium covered out there. It's safe. There's no explosion risk. There is no high pressure or anything like that. But last but not least, it's possible to transport this material. You can charge it in one geographical place, and you can discharge it in another place. Yep. This is describing where we are. We are at the end of our development phase. We are working with the pilots, and we take the responsibility of doing complete turnkey pilots because we are building a competence, and we're building the know-how of how to do those things. And this is very, very important in the future that we have that. We are not, in the long run, we are not going to build complete turnkey projects. We don't have that balance sheet, and we don't have that capacity to do that. But we by doing it in the pilot, we get the know-how and we know how to build it, and then we have to license it and transfer the technology fee to key partners in the future. So yeah, we are we have soft money. We have partly financed the Stockholm pilot with soft money from Berlin, from Energimyndigheten in Sweden, and it's very important. But we want to come to a pre-commercial situation. And what do I mean by pre-commercial? Well, that's when the customer is paying, well, hopefully everything, but at least a part of it, to be strongly committed to build those things. And the ongoing pilots, Shanghai, it's we're talking with them at the moment, so they're not very active at the moment. Stockholm is the area where we are really making the focusing on a 100, 200 kilowatt solution. And Luleå, that the pre-study is going on until the end of the year. But 2023, we plan to do those pre-commercial pilots. And 2024, in the beginning or at the end of 2024, we want to have at least one commercial project of the 5 megawatt size. So this is the road map, the go-to-market map that we see at the moment. And it's going to be both, as you can see, power to steam and heat to heat. Yep. So Harald, now it's your turn.
Thank you, Carl-Johan. I have two comments. One, we are pleased to announce that we in the period have had some revenue, not of any size, but just the fact that we've had some revenue, and it's coming from a consultancy assignment, a support that we have been asked to perform for one of our partners. And this is just the first payment, the first part of the revenue that we could recognize. And it's not the fact that it's the money or that it is something that we plan to live off from going forward, but it demonstrates the close cooperation we have with our partners and the confidence they have given us that we can perform also services for them that they're prepared to pay for, which is pleasant. The second comment is much like in previous quarters, and we have described our activities in this quarter. Carl-Johan has done that. And so we have funded the plant outside Stockholm, and that's what the money has been used to, in addition to some of the work up in Luleå and some of the work here in our own premises, in our own laboratories. That cash flow varies, has more to do with payments in advance to these suppliers for the Stockholm plant. But in general, that's what we have been doing, and that work continues into Q4 in the beginning of next year. So thank you.
Mm-hmm. Thank you, Harald. Questions? We have a question of the shipping procedure. Is the shipping procedure complicated? If you were to ship the charged salt by ship, does it then need special containers? Can it get wet during shipping from rain or moistures, or is it critical to stay dry? Can the charged salt be destroyed during the shipment? How is the shipment by land, special trucks, etc.?
You or me? Go ahead.
We have looked into this, of course, and this is fully possible to do the shipment. You don't need any special designed containers or anything like that. You have to get sure that it's not getting wet, but that's easy done. And this is a normal process today that when the companies are shipping this type of salt. So it's fully possible, and it's more difficult to find the application when it comes to this. we call it a TESS, by the way, transportable energy storage system. That's our concept. But talking about the waste heat, as we were talking about, you certainly have a lot of waste heat in certain geographical places, and you have the need of the energy somewhere else, and that is really a very, very interesting opportunity. And if where you have those waste, you often have either you have a close to the water industry, or you have an industry in the middle of the country also. But very often those companies have railway, and you can also transport it on a train here, which is also fully possible. So special trucks, I think you should, when it comes to the business case, it's getting more economical to use train or boats here, or ships. Special trucks could be used for a certain smaller amount of volume, yes, but we are talking about quite many trucks. If you're going to, I mean, we're talking about thousands of tons here. So the cases that we have looked into has been more into the train and boat system. You want to add something there, Harald?
No, I'm fine. I'm fine with that.
Okay.
So there are no further questions.
Any more questions?
We just have to wish each other a happy All Saints Day.
Good. Yes. Okay. Thank you for calling in, and keep up the good work. Yes, we will. Thank you very much. Bye-bye.